Uh, Welcome students to the first lecture video where we'll discuss regarding recursion or recursive function. So what is a recursive function? So what is the definition? See here. A function is called recursive if a statement in the body of the function calls itself. Okay, if simply if we'll say if a function call itself again and again, then we can say that is what recursion. So basically recursion is of two types. First one is your direct recursion, second one is indirect recursion. Okay, so see the example here. If two function, that is function 1 and function 2, okay, function 1 and function 2, then what is the direct recursion? So direct recursion can be demonstrated as, see here, suppose this is function 1, okay, function 1, so this is the body of function 1, you see, so this is the body of function 1, so this is the body part of the function 1. So inside this body again we are calling this function 1. So what happens, we are calling the same function inside this function. Okay, so that is known as what recursion. So every recursive function should have an exit condition. Okay, and why we are using recursion, what is the use of recursion in our program is generally to avoid looping. So loop create a complex statement in the programming, so to avoid looping, to make the program simple and faster, what we are using what recursion. So every recursion should have an exit condition, otherwise it will execute infinite. So there is an infinite execution if will not have any exit condition. Okay, so this is what direct recursion. Then see what is indirect recursion. See here. So indirect recursion can be demonstrated as, see here, function 1. This is function 1. Inside the body of function 1 we are calling function 2. So when we'll call function 2, the control will go to here function 2. And see here inside the function 2 what we have, function 1 we are calling function 1. So calling function 2 is indirectly calling what, function 1. So it is known as what, indirect recursion. Okay, so now we'll take an example. So what is, write a program to find, so the find factorial of a number. Okay, so write a program to find factorial of a number using what, recursion. So it is a very common example, and we know what is the formula for recursion. If we, that means to find out the factorial of a number, that is if it is n factorial, then n into n minus 1 into n minus 2, like this. Okay, we can say this is generalized format. So if we formulate this common expression, it is like this: n factorial is equal to n into n minus 1 factorial. For example, suppose I want to find out the factorial of 5, then I can write 5 into 4 is n minus 1, 5 minus 1 4, then 4 minus 1 3, then 3 minus 1 2, then 2 minus 1 1, then 1 minus 0. So 0 factorial is 1, we know. So the result is what, 24. Okay, so now we'll write a program, okay, to demonstrate the recursion. Okay, so see here. So see here, that is so I'm writing the prototype, or sorry, the definition of the factorial part. I'm writing the logic only. See here, I'm not writing the complete program, rather I'm writing the logical part. Okay, so we'll define a function that is int. The return type is int, then name of the function is what, factorial, and it will pass an argument that is n. Okay, so if n is equal to 0, then fact is equal to 1. Okay, if n value is 0, then it will return what? 1. Else what will do, we'll write this formula: n into factorial of n minus 1. Okay, return then fact. This is the result will be stored here in the fact. So this is the recursion here. So this is the recursion process. So this function call itself, okay, until there is an exit condition. See, okay, so suppose you are taking the n value is 4. Okay, so now n, we have passed the value of n is equal to 4, so n not equal to 0, so we'll come to else what. Then what to write? 4 into n minus 1, that is 3, that is factorial of 3. So see this condition, this one, 4 into factorial of 3, that means we are again calling this function. Which one? This one. So where n value is 3. Okay, now 4 into 3, so n value is 3, so 3 into factorial of n minus 1, that means 3 minus 1, so factorial of 2. Then again we'll calling this function, so n value is 2, so 2 condition is false, come to else what. Now 4 into 3 into 2, then factorial 2 minus 1, the factorial of 1. Okay, so now n value is 1, which is not equal to 0, then come to else what. Then 4 into 3 into 2 into 1, then factorial what, 1 minus 1, that is 0. Now n value is what? 0. So if n equal to 0, then factor equal to 1, so it will return what? 1. So finally what will get? It will come like this. So 4 into factorial of 3, then 4 into 3 into factorial of 2, it will work internally like this. Okay, so 4 into 3 into 2 into factorial of 1, then into factorial of 0. So this is the exit condition, you see. Okay, so this is the exit condition. Here we'll get what? Fact equal to 1. Okay, so finally we'll get the result, that is what? 4 into 3 into 2 into 1. Okay, that is equal to 1 into 1, that is equal to what? 24. Clear? So we'll take another very common example that comes in the exam very oftenly, that is the Fibonacci series. Okay, so already we have studied how to write Fibonacci series using array, in array concept. Now we'll study how, means using loop. Okay, using loop we can find out the Fibonacci series. Now we'll find using recursion. See how. So already you know what is Fibonacci series. Okay, so now I'll write here the program. So has include stdio.h, then we'll write the function prototype here. Then function name is fiv, then we'll pass the what type only, no variable, only type is a function prototype, so no variable is declared here, only the type of the variable will be declared. Then inside the main function we are taking 3 variable I, n and f. Then enter number of terms to be what? Enter number of terms to be generated, so up to which we want to generate the series. Then you have to input the number, that is scan a percentile d ampersand n. Then we'll use a for loop here for I equal to 0, I less than n, I plus plus. So here we'll call the function fiv of I. Okay, fiv of I. Then this, so we have defined this function here. So here we are passing the argument intn. So if n equal to 0 or n equal to 1, then what will return? N. This is the exit condition, okay, of the program. If n equal to 0 or n equal to 1, then return n. Okay, else return fiv of n minus 1 plus fiv of n minus 2. Okay, so after getting the exit condition, it will print the series. Okay, gradually. So how it works, see here. Suppose we have given enter number of terms to be generated. Suppose we have entered 5, so the number of terms to be generated is up to 5. Okay, so you have taken the input as what? 5. So now see here, so I equal to 0, I less than 5, so 0 less than 5, okay, condition is true, so come here, so fib 0, fib what? 0. So now we'll call the function, thus it will come to here. So what is the n value? N value is here 0, so 0 equal to 0, so condition is true, okay, condition is true. So what will return? Return n. So it is our condition. If this condition is true, also return n, or either or case, or if n value is 0, return n, or if n value is 1, return n. So here n value is 0, so return n. So n value is what? 0, so it will return what? 0. Percentage f 0, so it will print what? First 0, it will print 0. Then the I value is incremented, that is what? 1. So now fib of I value is what? 1, so we will calling the function fib I. So now n value is also what? 1, as I value is 1, so n value is also 1. So here n equal to 0, no condition false, it will check this condition, yes true, so return what? 1. So now 1 will be printed here, okay, so 1 will be printed. Then the value of I will be incremented, that is 2, so 2 less than 5, yes. So now I value is 2, come to here, this condition is false, okay, so n value is not 0 or 1, so come to the else part. So fib n minus 1, so what is the value of n? N value is 2, so what will write? Fib 2 minus 1, that is fib of 1 plus fib of n minus 2, that is 2 minus 2, so fib of what? 0. So fib of 0 will return what? 0, we know. So when n value is 0, so the fib 0 means we are calling this function. So n value is what? 0. So when n value is 0, to return what? 0. 0 plus fib value is 1. Now n value is 1. So when n value is 1, n will return what? 1. So 1 plus 0 is equal to what? 1. Okay. So return what? 1. So now it will print what? It will print what? 1. So first 0, then 1, then again 1. So this is the Fibonacci series, 0, then 0 plus 1, 1, okay, like this. Now the value of I is incremented, that is what? 3. So 3 less than 5, then fib of 3, so n value is what? 3. So this condition is false, come to else part. So fib of 2, n minus 1, so 3 minus 1, that is what? We can write what? Fib of 2 plus, that is what? Fib of n minus 2, that is 3 minus 2, that is what? You can write fib of 1, okay. So this function again will call, so fib 1, so 2 times this will call. So when fib 1 will, this function will be called, which one? This function. Now n value is 1, so 1 means it will return what? 1. So it will return fib 1, it will return 1. Then come to what? Fib 2, okay. Now n value is what? 2, so this condition false, come to here, again this will execute. So fib of 2 minus 1, so fib of 1 plus what? Plus fib of 2 minus 2, fib of 0, so n value is 0 means it will return what? 0. So that is fib of 0. So fib of 1 return 1 plus this 0, it will return 0 plus 1, so it will return what? 2. So now n is what? It will be 2, it will print what? So 1 plus 1 is, it will print what? 2. So likewise it will continue and will print what? Up to the 5th term, okay, 5th term. Okay. So this is 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, like this it will print, okay, up to 5th term. 1, 2, 3, 4, 5, up to this will print, this will not print it. So up to this will print, okay. So this is regarding all about what? Your recursion and example of recursion. The next class we will study some other applications of the recursion. Thank you.